You know, every single business out there, yours included, runs on data. But let's be honest, how do you actually protect it? Well, today we're going to look at how you build a digital fortress. We're diving deep into the architecture of NetApp ONTAP to see exactly how it keeps your data safe, sound, and always available.
So let's just kick things off with a big question, one that's kind of at the heart of our digital world. How in the world do you protect something you can't even see, that exists everywhere at once and is, without a doubt, the most valuable thing you have? Because that's what data is. It's the lifeblood of your business, but that also makes it incredibly vulnerable.
Well, the answer is you don't just store it, you have to fortify it. You need to engineer a system that's so smart, so robust, that it can handle pretty much anything thrown at it. Hardware failures, unexpected glitches, you name it. In other words, you build a digital fortress.
Okay, so every great fortress needs a solid foundation, right? For our data fortress, that foundation is all built on the core ideas behind ONTAP's architecture. So let's start right there, at the very beginning.
First things first, what even is ONTAP? The best way to think about it is as a storage hypervisor. It's like the master brain of the operation. It takes all the physical stuff, the disks, the processors, the memory, and it weaves them all together into one single intelligent system.
Now, the absolute fundamental building block of this whole fortress is what's called an HA, or High Availability Pair. This is the cornerstone of how ONTAP stays so resilient. It's a setup where two controllers, or nodes, are constantly linked up, watching over each other, just ready to jump into action in an instant.
And this slide just nails the concept perfectly. Think of it like a pilot and co-pilot system for your data. If the main controller, our pilot, runs into any trouble, the co-pilot takes over immediately and seamlessly. And the best part? The passengers, which are your applications, they don't even know a switch happened.
All right, so we've got our foundation, but what's a fortress without guards, right? In the digital world, guarding means protecting the data itself from getting corrupted or worse, lost. So let's look at how ONTAP makes sure your data integrity is rock solid.
So the first line of defense is this really cool thing called NVRAM. And you can just think of it as a crash-proof notepad. See, before any data change gets written to the main disks for good, a quick note about that change is jotted down in this special memory. And this memory? It survives power outages. This is huge, because it means no write ever gets lost if the power suddenly cuts out.
So here's how that safe write actually works in practice. Let's walk through it. A write comes in, right? Then, look at step 2. It gets logged to that crash-proof notepad, the NVRAM on both controllers. Now here's the magic. Step 3, only after your data is safe and sound in two separate physical places does the system tell your application, yep, write complete. The final slower step of writing to the actual disks can happen a moment later. This gives you amazing performance without ever risking your data.
Okay, but what about protecting the data that's already on the disks? Well, a lot of older systems use something called RAID 10. It's fast, sure, but it has this little known weakness where if two specific disks fail, poof, your data's gone. ONTAP uses much smarter methods, like RAID DP and RAID Tech. These systems can handle 2 or even 3 disks failing at the exact same time without losing a single bit of data. And it does it all without the performance hit you'd see on older systems.
You know, a fortress that's all walls and no gates is pretty useless, right? It's not just about defense. It has to be functional. It needs to deliver the goods, or in our case, the data, really fast. So let's talk performance.
This chart shows a really simple but super powerful idea. By spreading your data workload across multiple LUNs, which are basically just logical containers, it's like opening up more checkout lanes at the supermarket. And what happens when you open more lanes? The lines get shorter, people get through faster. In the storage world, that means less waiting, or what we call lower latency.
But how does the system even know which lane is the fastest? Well, that's where this clever feature called ALUA comes into play. Just think of it as a built-in GPS for your data. It's constantly looking at all the possible routes from your application to your storage and telling the system, hey, this path is a direct superhighway and this other one is a reliable backup route.
So during normal operations, everything's great. Your data is just flying down that direct superhighway. But what happens if there's a problem, like a cable gets unplugged or a switch fails? The system doesn't even flinch. That ALUA GPS just instantly reroutes the traffic down one of those backup paths through the partner node. The journey continues totally uninterrupted.
Okay, let's put all the pieces together now.
We've got the solid foundation, the data integrity guards, the super fast performance pathways. How does all of this combine to create a system that, let's be honest, is pretty much always online?
Let's just start with one single really powerful number. What if a whole controller fails? I mean, our pilot just passes out mid-flight. How long does it take for the co-pilot to take full control so that your applications can get back to work? The answer? Just 2 to 3 seconds. For your users, it's not some catastrophic outage. It's barely a blip on the radar.
And the system is always ready to go because it's literally designed to expect things to go wrong. A takeover isn't just for some crazy disaster. As you can see here, you can trigger it on purpose for maintenance. Or it can happen automatically because of a software glitch, a power loss, or even just a lost heartbeat signal between the two partner controllers. It's always watching.
And this quote right here from NetApp's own best practices, it really just sums up the whole philosophy. It's not about having one good path and hoping for the best. It's about building in redundancy for every possible scenario. 2 direct superhighways and 2 indirect backup routes. That right there is the secret to building for resilience.
And that really brings us to the final thought here. Building a true data fortress isn't about how much data you can cram onto some disks. It's about having an intelligent architecture that's built from the ground up with a plan for failure. So the real question I want to leave you with is this. Is your data just sitting there being stored, or is it truly fortified, ready for absolutely anything?